If you want to follow along, I recommend this dbfiddle website. It's a free website and you don't even need to create an account. When you open the website, just click on SQL Server, that's the flavor of SQL that we're using for these videos, and make sure you choose AdventureWorks as the database. That will give you access to all of the same sample data that I'm using in these videos. This time we're going to talk about data types in SQL, data types in databases. Excel does have some idea of data types. We know that there's a difference between numbers and text. For example, we know that this is a number and this is some text. One of the things that Excel does to make this clear to us is it always puts numbers on the right of the cell and it always aligns text on the left of the cell. We also know that data types are important. There's certain things that we can do with some type of data that we can't do with other types of data. For example, I can add 1 to a number, but what happens if I try to add 1 to some text? It doesn't work. It doesn't know how to add 1 to some text. It's the same in SQL. SQL is going to allow us to do some kind of operations, some kind of manipulation on data, depending on the type of data that it is. Just to stress this a bit more with Excel, you may have had issues in the past with text that looks like a number. For example, we can do 1, 2, 3 in double quotes, and this will save 1, 2, 3 as text, not as a number. You see it's been aligned to the left of the cell now. Similarly, we could start the cell formula with a single quote mark and type a number. It will still tell Excel that that's how we want to treat it as text. So what happens if we try to add 1 to these ones? Well, even though these are text, Excel understands that it's text that represents a number. So what it can do behind the scenes, it can understand that we want to treat this like a number even though it's text, and then add 1 to it. And see now, because when we do the +1, we've got an output as a number, Excel keeps the output justified on the right of the cell, aligned to the right of the cell. We're going to see that SQL can do similar things. Even if the data isn't necessarily the right type, even if we've got a number that's saved as text, we'll see that SQL, just like Excel, can understand that we actually want to treat it like a number, and it will implicitly convert it into a number before it does any kind of operations with it. Before we look at any other examples, let's have a look at what data types are available in Microsoft SQL Server, the SQL flavor that we're using for these videos. I'm just going to open up the Microsoft documentation so we can have a look. I'll keep the link in the description. We saw that Excel has numbers and it has text. They're the two types that Excel has. What about Microsoft SQL Server? It actually has loads of different data types, and we can see that even something like numbers, well, it has loads of different number types. We've got some that are just for whole numbers. We've got some that are for whole numbers but they're small. We've got some that are supposed to correspond to money, some currency. We've got ones that correspond to numbers that have a decimal place. We've got these other ones as well which have a lot more decimal places. So numbers alone have loads of different data types. Now we're not going to explain each of these in this video. We're going to call out a couple of the important ones, some of the ones that you're going to be working with the most, and I'll leave it to you to then get familiar with these in your own time. In reality, the ones that we go through today should be the only ones that you need to work with on a day-to-day basis, aside from odd edge cases. But just note that we're not going to be going through all of these today. What other data types are there? We've also got date and time data types. We'll make a comment about how Excel treats dates shortly, but there's a specific date type, a specific time type, specific date time type where you want date and time together in the same data. There's also then lots of different text data types and various other data types as well for slightly different data that we typically wouldn't see in Excel. What's the point of all of these data types? In SQL, every column has to have a data type. SQL needs this. Databases need their columns to have specific data types because that's how it can know what kind of operations it can do with that data. It has other impacts under the hood, behind the scenes, that you don't need to worry about, like the amount of space that it's going to take up, the amount of memory that it's going to take up with that data. But for what we're going to focus on, we're just going to focus on how it impacts the way that we write our code and some common pitfalls that we can avoid if we keep the type of data that we're playing with in mind. I'm going to make a quick point about the difference between the data types and the data formats, because this is the data format. It's more of an Excel concept than it is in SQL. So I just want to make sure that you know that it's kind of stuck to Excel, and that although there is a way of thinking about it in terms of SQL, it's a little bit different. Let's start with the number 1, 2, 3, 4. What number format can we apply to this? Well, let me quickly pin the ribbon. So 1, 2, 3, 4, this is the basic format for it. We can do things like make it specifically a number, something with decimal places. This will then show us the decimal places. Of course, we can always increase or decrease them however much we want. We can format it as currency by putting in a currency symbol and 1,000 separators. Since I'm in the UK, it's the pound symbol with commas and full stops for the decimal separator. We can even do dates. So the number 1, 2, 3, 4 corresponds to the date 18th of May 1903. We're going to see more about this later on, but the point I'm trying to make is that these are all formats. They're just changing how the number looks, but it doesn't change the number that's actually there. The number that's actually there is still 1, 2, 3, 4. We can't apply formats in the same way in SQL. What we can instead do is we can convert the number into some text with the format that we're after. Say with a pound sign or a dollar sign or any kind of other currency sign. We can do it with decimal places if we wanted to. So just keep in mind, in SQL, there isn't this concept of formatting without changing the underlying data. This is specifically an Excel thing. How do we convert different data types in Excel? Well, let's say we've got a number stored as text. Let's choose 1, 2, 3, and I'll use the single quote at the start to tell Excel that this is text. It's text because, or we can tell that it's text because it's aligned to the left of the cell. What options do we have for turning this into a number? What explicit options do we have? Well, we can do things like using the value function. Yeah, that's converted this text, the text 1, 2, 3, into the number 1, 2, 3. There's also other ones. There's number value. This is a function that we can use as well with just a few more options. It's a bit more flexible than the value function. These are both options for converting text into a number. And this is the explicit way to do it. Remember, we saw that if we wanted to add 1 to some text that represents a number, behind the scenes Excel is going to do whatever these functions do. It's going to convert it into a number first, and then it's going to add the 1 to it. So this is implicitly converting this into a number and then adding 1 to it. Both of these are explicitly converting it. We can go the other direction as well. So if we've got 1, 2, 3, the number, we can turn it into text. There's a few ways to do it. My favorite is the text function, because then you can provide some format to apply to it. Just do hash for now. That's now left aligned it. Let's put it on the left to tell us that it's text. Since Excel only has the 2 types, number and text, it provides specific functions for going between the 2 of those. But what about SQL? We've seen that SQL has a lot more types. So if there was a specific function for every possible combination of between types, that would be a lot of different functions. So instead, SQL has one main function that we use to convert data, to convert the type of the data. And we use it in very similar ways to the ways that we've used these 3 functions here. So let's do the same thing with SQL. This is a place where I'm going to do a select with no from. Remember, we saw in selecting from that the from is actually optional. Because I'm just messing around with some very simple small examples, I'm not going to bother with a from. We're going to start with some text. Say 1, 2, 3 as some text. I've written my code, now let me run it. In the same way that Excel aligns things to the left or the right to tell us whether it's a number or some text, the SQL program that I'm using is doing the same thing. Let's put 1, 2, 3 on the left to tell us that it's some text. It's a text data type. How would we convert this to a number? The function that we use is cast. We want to cast some data into a different type. So let's take this 1, 2, 3. Now we also need to tell it what type to turn it into. And cast is a bit of a special function because we actually reuse the as word that we've been using to rename or alias columns so far. We use the as here as well. But instead of giving it some name, this is where we specify the type that we want it to be. So for now, I'm going to choose this integer type. We're going to explain what integer is a little later on. I'm just going to call this some number. I've updated my code, let me run it. And here we go, it's right aligned 1, 2, 3 to tell us that it's a number, specifically an integer, rather than text. So cast is just like using value or number value when we say cast whatever it is to an integer. Of course, I've specified a specific value here, but you could also write a column name here as well, which we'll see later. What about the other direction? So we also did the other direction with Excel. We took the number 1, 2, 3 and converted it into the text 1, 2, 3 with the text function. What can we do with SQL? Well, let's start with 1, 2, 3 as some number. I'm going to give this a run. It's aligned on the right, so it is indeed a number. We're going to use the cast function again. And this time, the type that we're going to convert it to is VARCHAR. Just like with integer, we're going to explain what this means later on. Let's now call this sum text. I've updated my code. Now I need to run it. We've got exactly the same thing. It's converted the number, which is right aligned, to the text, which is left aligned. All we needed to do was tell SQL which specific type do we want to convert it into. So this cast function is really flexible. It can go from any type to any type, more or less. So this is a really, really important function to know. In Excel, you stick to value, maybe number value, and text. With SQL, you stick to cast, and you specify the type that you want to convert it into. But to use the cast function, you need to know what types to convert into. So let's talk about what data types are the most important ones for you to care about, at least for right now. We saw earlier that there are a few different data types that we can use for text in Microsoft SQL Server, the SQL flavor that we're using in these videos. The 6 of them, just written here: char, varchar, text, nchar, nvarchar, and ntext. I'm actually going to just completely ignore the ones with the n at the start. We're just going to skip those. And in fact, text is being removed from SQL Server in a future version of SQL Server. So we're going to ignore that as well. We're just going to stick to char and varchar. So what are char and varchar? Char is short for character or character string. So this is a piece of text. Similarly, varchar is then short for variable width character or variable width character string. What does this mean? Why is there two different ones? Well, for reasons that we're not going to go into, sometimes it's convenient to say that the text in a column is going to be a specific length, or that the text in the column is all going to be lots of different lengths. Char would be used where the data in that column is all the same length, or more or less always the same length. This might be codes for something, you know, it's always going to be a 4-character code. Varchar, on the other hand, is for text in a column that might be some variable width. It could be, I don't know, comments on a post. Some people do really short comments and some people do really long comments. Since it matters more for saving the data, whether you use char or varchar, we're actually going to skip char. We're not even going to talk really much about char anymore. We're just going to stick to varchar for the time being, because anything that you're doing, it's likely that you're just getting some data. If you're actually creating tables, then I encourage you to look into the use cases for char versus varchar. But if you're just writing select queries, you can get away with just sticking to varchar, at least until you're comfortable enough with SQL as a language that you can look into the different data types and when you would use the other ones. So we're just going to stick to varchar. Although I am saying this as an English speaker working with English data. If you are working with any data that isn't based on English, like English language, then I would maybe recommend doing nvarchar instead. The main difference that you need to worry about is that nvarchar supports more characters than varchar does. There's other differences, but that's the main thing to be aware of. So we know that varchar is text. We know that we're going to use the varchar data type anytime we see text. What does that mean? Well, we've already seen an example of this. Let's just quickly remind ourselves we did the cast function to turn the number 123 into the text 123. Just as a reminder, if I do 123 by itself, 123 is right aligned because my program, just like Excel, right aligns numbers, and the second 123 on the left because my program, like Excel, left aligns text. I said earlier that although we've used a specific value in the cast, we can use columns. So let's quickly do some work with the department table again. So let's look at human resources.department. Let's just grab for now the department ID. This is right aligned, so we know it's a number. And in fact, if I hover over the column in my program, it tells me that it's specifically a small int, a small integer. We'll cover that later. If we wanted to, for whatever reason, convert this into text, we use the cast column. Let's convert it into a varchar, just like we did with our 1, 2, 3 example. Let's call it department ID text. We get exactly what we'd expect. All of the numbers are now left aligned because we've converted them into text. It's worth knowing as well that I've been a little bit lazy here by writing varchar by itself. It's more common to see varchar followed by some brackets filled with a number, which represent the corresponding length of the data in that column. So in this case, the 100 means for a varchar that I don't expect the data to ever exceed 100 characters. If this was char, then I'd be saying that I don't expect, or that I expect all of the data in this column to be 100 characters. If you do not specify a number in brackets after varchar, it will just use some default value. We also saw a lot of the number data types that SQL Server has. Just like with the text data types, we're not going to go through all of them. In fact, the only ones that we're really going to go through are integer, big integer, and decimal. The rest of them, they're useful to know about, but they're outside the scope of this video. So get to grips with these three, and then once you're ready to move on from these three to get to know the other ones, I strongly encourage you to check them out just to see what makes them slightly different from the three that we're covering today. Before we talk about the three of these individually, what is integer? Well, if you've not come across integer before, integer is just the mathsy name for whole number. A number without any decimal part. So 1, 2, 3, these are all integers. 1.5, that's not an integer because it's not a whole number, it has a decimal part. We've already seen how we can use integer. Let's just quickly remind ourselves, we did select 1, 2, 3. We wrap this in a cast. We'll cast this as integer. Note, you can write int for short. Int is short for integer, which is why we have BIGINT as big integer. But let's run this just to make sure that it works. Of course, we get 1, 2, 3 aligned on the right hand side because we've asked for it to be an integer. We've asked for it to be a number. When would we use BIGINT or decimal instead of integer then? Well, one place that you might want to use BIGINT is if you're working with credit card numbers. Let's see what happens if we try to use a credit card number. So a credit card number's got 16 digits. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to repeat that. 1, 2, 3, 4, 5, 6, 7, 8. So this is a typical credit card number. What happens if we try and convert this into an integer? We get an error. I appreciate it's quite small, but we can't convert this into an integer. This number, this 16-digit number, is too big to be converted into an integer. So when we've got numbers this large, and we need them to be numbers rather than keeping them as text, we need to use BIGINT instead. BIGINT. I've updated my code, let's rerun it. Now it's absolutely fine. It's happy to treat this as a number. We can't really tell the justification, so let me just expand that. It is right justified. It's aligned to the right of the cell, so this is indeed a number. BIGINTs don't crop up too often, But if you see any error trying to do a conversion with an integer, and it's saying something about overflow, that means that the number that you're trying to convert, the string, the text that you're trying to convert into a number, is too large to be converted into just a normal integer. And in that case, try using BIGINT instead. But like I said, BIGINT isn't super popular. You shouldn't see it too often. What about decimal? When would we use decimal? Well, let's bring up our favorite example again. Let's do 123 as text. I want to convert that into an integer. What if we add some decimal places to the end of this? Let's say it's 123.45. What do we get when we try and run this now? Well, we're going to get another error. This time, we're not getting the error because the number is too large to be an integer. We're getting it because this isn't an integer at all. So SQL doesn't really know what to do with this. And just to prove it, BIGINT also wouldn't work. We still get the same error because it's not an integer. This is a number, but it's specifically a decimal number. It has a decimal place. So what do you think? Convert into decimal? Do you reckon this will sort it? Not quite. And that's because, like VARCHAR and CHAR, decimal also needs some numbers at the end. It actually needs two numbers, which makes it slightly different to VARCHAR. The first number is the amount of digits that we're going to have in the number in total. So in this case, we need, we're going to have 3 at the front, 2 at the end. So that's going to be 5 in total. And the second number is how many digits we have after the decimal place. In this case, it's 2. So we're saying that this is going to be a decimal with 5 digits in total, 2 of which are at the end. Let's give this a run to see what we get. There we go. Now SQL is happy to treat this text as a number. We can put pretty much whatever numbers we want in the end, but we just need to make sure that they're large enough, unless we specifically want them to be too small. And what does that mean? Well, if we had chosen to put 1 instead of 2 at the end, what do you think is going to happen? Well, we've only asked for 1 decimal place, so SQL is going to round the number here. 0.45 rounds up to 0.5. So it's just showing us 123.5. Similarly, what if we did have enough decimal places, but we didn't specify enough digits in total? What if we did 22? Well, this is now the same error that we had with trying to convert the credit card number into an integer. We're saying that we need 2 digits in total. This is more than 2 digits. So it's throwing an error. So we can be a bit flexible with the second number to change the amount of decimal places that we want to show, but we need to make sure that we at least get the first number correct. We need to make sure that we always get the right number, or at least the smallest number possible for the amount of digits that we're going to have here. So just to prove this, I could put 20. That's definitely going to be small enough. But in this case, 5 would be the smallest that we need. Anything smaller than 5 would be an error, because we're saying that we need less digits than we actually need. Let's look at dates and times next. But first, let's recap how dates and times work in Excel. And if you're not actually sure how dates and times work in Excel, this is a nice bit of info for you. So let me pop in today's date. I'm going to do 2024-02-26. I'm in the UK, so it's doing day, month, year, but today's date, 22nd of Feb. This is a number, and the way that we can see this is by changing the number format. So it shows us a date here, and it shows us a date here. But if we change it to something like general, and remember this just changes how the number is shown, it doesn't actually change the number that's there, we'll see that this actually corresponds to the number 45,348. So behind the scenes dates are just numbers. Let's put this back. We're actually just going to do this. Let's reuse the function that we saw earlier. Let's reuse the value function, and we'll see the same thing. The value corresponding to this date, 45,348. It's the same with time as well. So let's do time as well. So 2024-02-26. Let's do 163000. Let's get the value corresponding to this. Well, it's the same number with 0.69 on the end. That 0.69 is the part corresponding to 4:30, corresponding to the time 4:30. So dates are whole numbers, and the time part of a date is then just the decimal part. So if dates and times are really just numbers behind the scenes, this is why Excel has that really flexible way of manipulating dates and times. If we want tomorrow, we just add 1 to our date. If we want yesterday, we just minus 1 from it. If we want next week, we just plus 7 to it. And in each case, the number behind the scenes is being updated, and we're just being shown the date that corresponds to that number. We can do the same thing with times. If we want to see this time, this date time in 12 hours, well, 12 hours is half of a day, 0.15. That will give us 4 AM tomorrow. That number corresponding to this date and time has just been incremented by 0.5. So Excel makes it really, really easy for us to update dates and times in a really intuitive way in Excel. We're going to see that SQL doesn't have this same convenience, at least not Microsoft SQL Server, the SQL flavor that we're using for these videos. We're going to have to use some specific functions to do the same things. So if dates aren't numbers in SQL, what are they? Or how do we define them? I think is a more helpful question. Well, they're their own thing. They're their own data type. They're no longer numbers. They're their own data type. So we can't just make one explicitly. But what we can do is we can use their string representation. So this is kind of like the opposite to what Excel does. With Excel, we think about them like numbers. In SQL, we think about them more like text. What do I mean by that? Well, if we wanted to define today's date in SQL, we'd do the text corresponding to today. And in SQL, we always use the universal date format. Other formats are supported, but I'd recommend always stick to the universal date format, which is year, month, day, separated by hyphens. This is currently the text corresponding to today's date. And if we run this, we'll see that this is text. So how do we turn this into a date? How do we tell SQL that we want this to be a date? Well, we need to explicitly wrap it in a cast function. We've already seen cast in action, and this is like using it with dates is just like using it with numbers and text. We're saying that we want this date, this particular text, to be a date instead. So if we give this a run, the output is identical, but SQL now understands that this is a date instead of some text. If we wanted a time part, we'll then just add in the time parts as well. So 3000, that means that we need to add time to the end of the data type. So date, time, and date time, they're all 3 separate data types in SQL. We can see it's now date time. Now that we know how to define dates and times in SQL, how do we use them? Well, let's just prove that we can't just add 1 to it like we could in Excel. Just focus on the date for the moment, for today's date. If we add 1 to this, what are we going to get? We get an error. Again, I appreciate you can't see it very well, but SQL, at least SQL Server, it can't just add 1 to a date, because SQL Server doesn't think that 1 corresponds to 1 day. So we're going to need to use functions, special SQL Server functions, in order to manipulate dates and times instead. The one that we're going to use is called dateAdd. DateAdd. Now this takes 3 different arguments. It has 3 parameters. The first is the unit that we want to add, whether that be a year, a month, a day, something else. Let's just do day for now. The second argument is how many of that unit we want to add, which can be negative. So if we wanted to do tomorrow, we'd do 1. If we wanted to do yesterday, we'd do -1 with the unit as day. I'll stick to 1 for now. And the last argument is the date that we want to change, the date that we want to modify. So we're going to put in today's date again. Let's give these a run to see what we get. And see that the 26th, the first one is today's date, tomorrow's date. If we add 1 to that, it's the 27th. So this has worked as we expect. And just to prove it, let's do -1 as well. So this should give us the 25th, which it does. It can take a bit of getting used to using this date add function instead of just +1 and -1. But the one convenient thing about it is that there's a very consistent way to add dates and times to your dates and times. So if we wanted to add a month instead of day, we just write month. Let's see what we get if we were to add 1 month and -1 month. Exactly what we'd expect. The 26th of next month, the 26th of last month. There's other date functions that are worth learning about. So I'd recommend spending some time getting up to speed with the date functions in Microsoft SQL Server. A lot of them are shared in other SQL flavors as well, but there are some, like this date add one, that are specific to SQL Server. Last up, we're going to talk about nulls. We mentioned these in a previous video, but now we're actually going to spend some time talking about them. Let's first talk about them in Excel, because Excel does actually have the concept of null. And then we'll do the same thing in SQL. So to help with this, I've got the example thrown up on the left here. This is a very simple table. It's got 5 rows. The first column is some text, and the second column is the length of that corresponding text. And then I've also got this count. Count the non-empty cells in the text column. So note that these 3 look non-empty, these 2 look empty. The lengths show us what we expect. There's no spaces in these because their length are 0. But the count of non-empty cells is given back 4. So what's going on here? So let's take a look at these values. Well, these 3 pretty standard. But this one, this is what we call the empty string. A string is just the coder's word for text. String being short for string of characters, so just text. So this is text. This is how we tell, the double quotes are how we tell Excel that we're going to be giving it some text, but we've just given it no text. So this is something, it's just that something is no text. Whereas the one underneath it is genuinely nothing. There's nothing here. If I was to hit the delete button, it doesn't change anything because there's nothing here. So this is something, it's just that something is no text, whereas this is genuinely empty. So of course this has no characters, so its length is 0, but this is still something, so it is counted by the count_a function. We'd see that if we were to whack this into a pivot table, the pivot table also treats the 2 of these differently. So let's quickly insert one. Let's just whack it here for the moment, and we'll just put the text as rows. So you see that the pivot table as well distinguishes between the empty string, the value that was here, and a genuinely empty cell, which it's called blank. We'll see that in SQL, what Excel calls blank, SQL calls null. And that's all it is. In Excel, blank just means the cell is genuinely empty. In SQL, it means exactly the same thing. The cell the cell in the table is just missing some data. We'll also see that we can define the empty string in SQL, but the empty string is different to null. So if I was just to rewrite these 5 lines in SQL, I'm not actually going to define a table in SQL. I'm just going to literally write these line by line, just so that we can see how we would write each of these in SQL. It's just like this. This is something. The next one was the empty string. It's just 2 pips. And the last one, we can't delete a cell with SQL, so we have to specifically write null instead. So we'll see we've got 4 non-null, 4 non-blank values, 1 null value, 1 blank value. The null is what corresponds to blank in Excel. And as soon as you keep that in mind, nulls make a lot of sense. Well, yeah, it's just whatever value in the table's been deleted or was just never filled in the first place. To wrap up, we've seen quite a lot of things in this video. We've learnt that in SQL, in databases, every column has to be given a specific data type. Those data types do come in categories like numbers, text, dates, whatever else, but there are lots of specific data types to be aware of. We've seen that for text, we'll use things like CHAR and VARCHAR, and if you're working with non-English data or emojis or anything like that, you would want to use NVARCHAR. We've learnt that if we're working with numbers, we can stick to integer for whole numbers, BIGINT if those whole numbers are just too large to fit in the typical integer type, and decimal if we want to use anything that's got decimal places. And with decimal, we also need to specify how many numbers, how many digits are going to be in that number overall, and also how many we want to see in the decimal part. We've seen that Excel dates and SQL dates are very different. Although Excel treats dates like numbers, and it also treats time like numbers, SQL doesn't do this. SQL treats dates and time a bit more like text. We need to use text to define our dates, to specify our dates, and we need to explicitly turn them into dates if we want them specifically as dates. And if we ever want to convert any of these to anything else, we need to use that cast function. Finally, we saw that null is a special value. It's applicable to all data types, but it's just like an empty cell in Excel. It just means that for whatever reason, there's no data in that particular cell. We've seen that it's different to things like the empty string. Null genuinely means there's absolutely no information there. I hope this has been useful, and I look forward to seeing you in the next one.